All right, this is in response to your question from our ACT practice packet. This is quite a complicated question, so I'm really glad you asked it. So I'll go ahead and read it. You are given the following system of equations: y equals x squared, rx plus sy equals t, where rs and t are integers. For which of the following will there be more than one xy solution with real number coordinates for the system? And they give you a whole bunch of options. So a few things I've noticed here is they said system of equations. That kind of hit something in my brain. They also have something where it says x squared. You'll kind of see that here in a minute. They also have something that says more than one solution with real numbers. And those kind of three different pieces are kind of the key, I think, to solving this problem. So I'm going to start off here with system of equations. System of equations makes me think of substitution and elimination. And in this case, because one of the equations has one of the variables all by itself, I'm going to use substitution. Okay, so I actually am going to just go ahead and rewrite the other equation, rx plus sy equals t. And we are going to replace the y with x squared, because that is exactly what it's equal to right here. Okay. Then I can see that this is now quadratic. Remember how I highlighted this as being quadratic? Hey, look, this is a quadratic equation. And the reason I know that is because we have an x squared term, we have an x term, and we have a constant term. And when we solve quadratic equations, we want to always have it be equal to 0. So what I'm going to do is I'm going to rewrite this in standard form and with it set equal to 0. Okay, so I moved the t over to this side, and I just swapped the positions of those two so that the x squared term is first. Now we have a quadratic equation with set equal to 0, so then that way now we can solve it. Okay, so then they say solve. And that's part of this solution thing here, is solving. Now there's a few different ways you can solve quadratics. You can usually do factoring. You can do completing the square. Or you can do quadratic formula. And so in this case, we are actually going to do quadratic formula. Boop. If you don't remember what it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now the pieces here of a, b, and c, this is going to be our a, the s value. The r is going to be our b, and the negative t is going to be our c. Don't forget the negative. That's super important on this question. Okay? So now I'm pretty much going to rewrite the quadratic formula, but I'm now going to substitute in our a, b, and c's into their right spots. So x equals negative, our b here is r, plus or minus the square root of b squared, b was r again, minus 4, and a is s, and c is negative t, all over 2 times a, which in our case was s. Okay, so I just substituted in the different values for a, b, and c into their correct places in the quadratic formula. Okay. Now, there's one more thing we're going to do to simplify in this quadratic equation quadratic formula, is I'm going to just make this r squared, And then right here you can see we've got a -4 and a negative t. -4 times a negative will become a positive. So this will become positive 4st over 2s. Okay. Now you might be already looking at this and saying, right there, r squared plus 4st. That's this thing right there. Well, it's that part right there. Okay. And r squared minus 4st is also there. Remember, if we hadn't had that negative there, it would have left this as minus 4st, which totally would have caught you up. You could probably do good test-taking strategy and just probably assume that, hey, that's what I got. I bet you that's the correct answer. And it is, but let's go a little bit further and I'll actually explain why that is actually the correct answer, okay? And it all comes down to this quadratic formula. Notice that it says more than one. So there is a way, sometimes we can get more than one solution. And with quadratics, that's usually the case. Usually we get x equals this and x equals this. Because a quadratic is x squared, usually looks something like this. There is at most two solutions, okay? So we got to figure out what those two solutions are, and how do we know that? Okay, it all comes down to this piece right here. And more specifically, this piece right here. All right, to continue our problem, I said it has something to do with this piece right here that's highlighted in orange. And it's this piece that's under the square root. That is actually something called the discriminant. You may not know what that term is, but there you go. Here's your vocab word of the day. And there's really three different choices. This discriminant can be greater than 0, which means that it's positive. It can be equal to 0, or it can be less than 0, which is meaning it's negative, okay? So think about it in this sense. So for like case number 1 here, if we had a number under a square root that was positive, like 16, and I keep that plus or minus piece right here and put it right there, the square root of 16 is equal to 4. So this would eventually result in plus or minus 4, which means that the two solutions are positive 4 and negative 4. That's two solutions. And are 4 and negative 4 real numbers? Yes. And when did that happen? It happened when the discriminant was greater than 0, when it was positive, okay? Now, if you think about it at this point, we've really answered the question because it says more than one solution that are real. 2 is more than 1, and these are both real. And when does that happen? When the discriminant is greater than 0, or when this piece is greater than 0. And that's why F is the correct answer choice here. In case you're wondering what would happen in these other two cases, is what if you had plus or minus the square root of 0? Okay, well, square root of 0 is just 0. So this would be plus or minus 0, but that doesn't really mean anything. The answer is still just 0. That's one solution, but it is still a real solution. But it's not more than one, which is what the question wanted. Then the third case here is if it's negative. If you had a number under the square root that is negative, like negative 16, well, you can take the square root of a negative number, but it takes you off into imaginary land. So this would become plus or minus 4i. This does give you two solutions, but in this case, both of them are imaginary. So which one of these three cases fits these criteria? They are real and more than one. Real and more than one is only this case right there when the discriminant is positive. Why F is the correct answer.